So we want to talk about being able to simplify radicals. And we're looking at radicals from the square root standpoint first, and then we'll look at some other ones. But there are a bunch of square roots that you should just kind of know off the top of your head, because square root means we're looking for the number that when we multiply it by itself, I'm going to end up with 16. That's not the technical term, but that's the best way to think about it when you're talking about square roots. So if I ask myself what number, when I multiply it by itself, I end up with 16, the only thing we would come up with, of course, would be 4, because again, 4 times 4 would give us 16. If I were to ask you, say, what is the square root of 1? And I know you like square root of 1, but yeah, square root of 1, there's only one thing that can happen. The answer would also be 1, because 1 times 1 is the only thing that would give me 1. If I did the square root of 81, you would go, okay, what two numbers? Multiply it by themselves, I get 81. There's only one thing that'll work. And that, of course, is 9, because 9 times 9 gives me 81. One more. If I did the square root of 100, you would say, okay, what times what? By itself gives me 100. Only one number, and that, of course, is 10, because 10 times 10 gives me 100. So that makes sense. Those are little easy ones. 4 times 4 is 16, 9 times 9 is 81, 10 times 10 is 100, 1 times 1 is 1. So you can pretty much go down your multiplication tables and find them that way. But what happens when you have a number that is not necessarily easy to break down? Say, for example, the square root of 28, where off the top of your head, you don't know what times what by itself, a number times itself, would give you 28. So whenever that happens, we have to do what's known as breaking down this radical. And the way we break it down is we have to think of what two numbers, when I multiply them together, I would end up with 28. What two numbers, when I multiply them together, I would end up with 28. So let's see. I can break down 28 into 2 times 14, because 2 times 14 gives me 28. Now, I don't want to confuse anybody, but sometimes it may help to strike out what you've already broken down, so you don't be like, okay, I have to break that down again. No. We want to break numbers down until they're basically in their prime form, or we can see a set of pairs. Well, it makes no sense to break down 2. I'm just going to leave that alone. But I can break down this 14. And 14 can be broken down into 2 times 7, because that will give me 14. That means I've already broken down this 14. So what I'm basically saying is that 2 times 7 is 28. And sure enough, it is. But because I'm looking for the square root of 28, I'm looking for pairs of numbers. I have a pair of 2's. So then I'm going to write square root of 28 to equal 2. But you also notice you have a 7 left over. Anything that you have left over is going to stay under the square root, because you don't have a pair represented. So I get 2, but I'm going to have to leave 7 under the square root. So my final answer is 2 square root of 7. Let's try another one. Let's say I'm trying to find the square root of 6. I don't know. 6? Yeah, 6. Let's break 6 down. 6 breaks down into 2 times 3. Can I go any further with this? Can it break down anymore? No, it can't. So I'm never going to get any pairs out of this. So guess what? The square root of 6 is going to stay square root of 6, because I never broke it down to get a pair of numbers. Let's try another one. Let's say if I wanted to do the square root of 44. Well, what two numbers when I multiply I get 44? I can get 44 from 4 times 11. That does give me 44. Okay. Can I go any further with this or with this? Well, can't go any further with 11. That's pretty much prime. There's nothing else I can do with it. But I can break down 4 because it will break down into 2 and 2. So, here are my pairs. So I have a pair of 2's. So my answer here would be 2 outside and square root of 11 left inside.